Hi, this is Mrs. Sjoberg, and I'm just going to work through the 7th grade Unit 4, Lesson 6 Desmos with you all. So on slide 1, it says, here are the scores from 3 different sports teams from their last 2 games. And I'm just kind of looking at this chart. So what do I notice about the team scores and what do I wonder? So if I look here, I notice that the football team, 22 points in game 1 and then 30. Basketball was 100 and then 108. And baseball was 4 and then 12. So something I notice is all teams scored 8 more points in the second game compared to the first. I'm kind of wondering if this 8 points means they're all getting the same amount better or not. Okay, I have a follow-up question. It says this: which team improved the most? Explain your reasoning. Football, basketball, baseball, they all improved equally or other. I think there's arguments that could be made for all of these. You might say they all improved equally because they're all getting 8 points better. But you might say something like the baseball team got the most improved. I'm going to say that because something I noticed about baseball, they went from 4 to 12. They improved their score by 3 times as much. But like basketball, they went from 100 to 108. They improved by just 8% or 8/100ths as much. So they were like 1.08 times better than their original score. So I might say something like relative to their original, baseball improved the most. Their score tripled. I might even say, because I noticed this was about percents, they improved by 200%, actually, because they were original 100%, then they got 8 more points, which 8 is 2 times as many as the 4, so 200% of their original was the improvement only. Okay. So in this year's March Madness tournament, our principal currently has 93.75% of the possible 320 points in the first 2 rounds. How many points does he have? To solve a kind of problem like this, when I'm trying to find 93.75% of 320, what I can do is I can change 93.75% to a decimal, move the decimal twice to the left. I'm going to have 0.9375. And oven math means time, so I'm going to multiply that by 320. You can certainly pull out the calculator and do 0.9375 times 320. And we should get that our principal has 300 points. So if I put this in, that's correct. And I can kind of check that if I do 300 divided by 320, that should give me that decimal. 300 out of 320 is 0.9375 or 93.75%. Okay, let's go on to the next slide. So a cereal box says that it now contains 20% more. Originally, it came with 18.5% or 18.5 ounces of cereal. How much cereal does the box come with now? So if I was going to solve this problem, there's a couple ways. You can do 0.20 or 0.2 times that 18.5. When you get that answer, you can add it to the 18.5 that was the original. So I can do that in one step. I could do 0.2 times 18.5. That shows me that it gets 3.7 ounces bigger. And then if I add that to the original 18.5, I can see I'm now at 22.2 total ounces. There's another way I can do this problem and just say like it's originally 100%, but it gets 20% more. So now it's at 120%, which means it's 120% of the original. And I can just do 1.2 times that original 18.5 in one step. So if I kind of put that in here, 1.2 times the 18.5, that's, I think, a little bit quicker, and you're still going to get the 22.2. So in slide 4, I can do something similar. Notice we already figured out this is a shirt, but it's $18.50, but it has a coupon that goes down, lowers the price by 20%. We already found that 20% of 1850 was 3.7 or $3.70. So I could just do that here, 18.5 minus 3.7. And again, you have your calculator to find that it looks like it's $14.80. I want you to note again, if we notice it was 100% and it took off 20%, you could say something like 100% minus 20% equals 80%. That they're spending 80% of the original, so they're doing 0.8 times that original 18.5. And if you notice that here, I could just do 0.8 times that 18.5, and I also get 14.8. So it's going to be good to be able to go back and forth with these two methods. All right, really important is 100% always corresponds to the original amount before the change. If a cereal box says that it now contains 20% more, we have an example of a percent increase. Here in this shirt problem, it was lowering by 20%. That's an example of a percent decrease. So we're going to look at these tape diagrams and just try to match each situation to the diagram. So let's try this. Compared with last year's strawberry harvest, this year's strawberry harvest is a 25% increase. So this year should have more than the original. That looks like it goes with A. We started with 100%. Now we have 25% more. This one, compared with this year's peach harvest, decreased by 25%. We should get lower. This tape diagram shows we're getting less by 25%. Notice this year's blueberry harvest is 75% of last year's. If you start with 100% and you go down by 25%, you're left with 75%. So this also matches this diagram. This one, it is 125% of last year's. If you start with 100 and go up by 25%, you're now at 125%. So it also matches this diagram. Noticing that these two things mean the same thing is really helpful. All right, looks like I got all the cards right. Yeah. So again, if you want to find a way to describe a 25% increase or decrease, if you go up by 25%, you start at 100, you're now at 125% of. If you go down by 25%, you start at 100, you're now 75% of. All right, we're going to try to draw out a diagram to represent this situation. So the number of ducks living at a pond in January increased by 40% by May. So if I had, we'll say, this diagram, and I started with this 100% in January, and then it increased by 40% in May, it would get bigger here. So it looks like for me, this top one would be 100%, and this bottom one would be 140%. This would be May, and the top one would be January. So it says the final May population is what percentage of the original January population? That's 140%. It just says that, so I guess don't put the percent in. I might have also chosen at the bottom to break this up into this, call this left one 100 and the right one 40. And then you're going to kind of get the same idea, but total is 140% of the original. Okay, so next one, the number of mosquitoes in Pennsylvania is 80% less than the number of mosquitoes in Alaska. So if I had this, I had Pennsylvania here. That's the original. That's, I'm sorry, Alaska's the original here. Alaska's my 100% here. So I've got Alaska 100%. Pennsylvania, it's 80% less. So if you're kind of thinking about where that goes, if we had this whole 100% and we take away this 80%, this is kind of just getting erased. So like 80% here, this is gone. All that we have left is over here, just this 20%. So 20% is all that's left when we took that 80% away, and that's Pennsylvania. So the percentage of mosquitoes in Pennsylvania is 20% of the Alaska mosquitoes. Yep, we got a lot of mosquitoes in Alaska. Okay. These are some great discussions for your class. I don't want to give them away, but it'd be really interesting to see whether you agree or disagree with each statement. There might be some room for debate here. I'm not going to give away slides 10 and 11, but I'm going to be really curious to look through and see what you come up with. And just when we synthesize, it's very important that you notice when a quantity is increased or decreased, what percent is the original or starting value. That's always 100%. And when you're trying to find two different ways to find a new value after original value is increased by 30%, one way that you can do it is multiply the original by 0.3, which is 30%, and then add it to the original. That's kind of like the 6th grade level way. Or you can move up to the 7th grade sophisticated way, which is add 30% to 100% to find 130% of the original, which means you just do 1.3 times the original. That way it ends up being more efficient, and we'll need to get to that level in this lesson. All right, I hope you're doing okay, and I hope I can see you next week.